I am Paul Evans. I'm with Daystrom, and we come from it from a storage and a data perspective. We work with people with lots of data, namely you, and you ask us, how do we store this most efficiently so it can be accessed quickly and not cost a fortune? And so taking that task, we have sort of forked one of our issues around file systems, and we started to ask ourselves, well, what do we need to deal with on security? So we went back 200 years and said, all right, where does this all come from? Because distrust and caution are not words that we really love to embrace. They're necessary, but if that's the basis of security, how much do I love security? Well, then we went out and looked and saw, hey, there's a really big problem out there. It's very clear that we're not doing as well as we ought to be regarding security. Now, these are taken from other parts and other industries, but this industry, of course, has been hit hard. And so then we saw, well, what's really going on real time? And we discovered there's a lot of attacks constantly. And a lot of the technologies and a lot of the focus has been outward, right? So these real-time maps are now available. This is just one slice. There's a lot more going on. But then going on, we thought, well, where are the real problems lying? And there's a lot of great reports. So Mandiant, Verizon, the NSA actually has great reports to read on this topic. They all said a lot of things, but they narrowed it down to what we found as three standouts. Credentials, not working so well. Alert overload, we can't tell what's good from the bad, and so we tend to do nothing, and that works against us as well. And then what we call egress blindness, meaning we're not really looking at the things that are walking out the door. We're so focused on what's trying to come in and get us that we don't get a sense of the important things under our nose. So again, we're at the storage layer, we're at the data layer, and we're thinking, well, what can we really do to focus on that? We discovered that, sure, this is mostly what we call the layer 8 problem. For those of you in the networking space, you know that the technology lives between layers 0 and 7. We're at 8. And so what we need to do is change our mindset a little bit, as was referenced by the previous speaker. We need to stop trying to undo all the things that are supposed to make us secure. We need to start doing things that, as was said, create less friction and are successful. So we took that back to the layers that we really live at and asked ourselves, what can we do? And we came up with 3 things right off the bat that we should really be focusing on. First, we should work more like a team. And I'm as guilty as anyone in trying to work with the security teams. Security slows us down, it makes it more complicated, and it creates friction, especially if you're trying to go really fast, which is a lot of what our technology does. So if the attackers are teaming up, we need to do the same thing. Trust but verify, a great Russian proverb. Looking for different ways that we could be authenticating the users. If credentials are a key problem, then why don't we rethink this game a little bit? And then boundaries. The cloud is everywhere. The cloud has very few boundaries. We still do security in a very perimeter-centric way, and that's probably not going to work for us. Clearly, it's actually not working for us. So first off, if we dive deep on the how do we work as a team, some quick low-hanging fruit. We could be providing more information into the security team in a machine-centric, machine learning-capable manner, which would let us drive a lot more analytics about what's going on with the files and the access and where they're going and what the patterns are. We could do a lot more than we do today. Those technologies are available, they're easy. It doesn't affect the users. This is all happening in the background. Let the analytics do the work for you, and then start to understand when data is actually leaking out the door, right? That egress problem. Also, we could start to connect these together. I'm sure you've heard the buzzwords software-defined this, software-defined that. Software-defined stuff can connect together and provide that responsiveness that is a lot easier to work with than keeping an administrator in between every action and every alert. If we're still trusting the security team to do step-by-step analysis and then take action, it's not going to work. So we need to figure that out. This needs to get better. The software is capable of doing it. Now we need to cross a lot of the other boundaries that are not technical. Trusting. So real easy step. We could go to 2-factor authentication. Something I know, like a password, and something that I happen to have with me, a token. But going beyond that, we really should start to look at the context. If that user has been properly authenticated, where did they authenticate from? Geolocation isn't that hard to do anymore, so we should be factoring in location, time of day, a lot of other factors about the credentials, because that's the weakest point in a lot of these chains is when a credential is compromised. And then boundaries. Clearly, I can't figure out where to draw those anymore, so I should probably stop trying to draw boundaries. The whole perimeter defense thing has failed us miserably. And so what we need to do is take that perimeter down to whatever the object it is that needs to be protected and keeps moving around. So from you call it an object, you call it a file, you need that kind of protection built into it itself. So what we end up with is kind of only one solution if you really want to protect the data, and that's encryption. Now, encryption today is fast. It uses open standards. It's very practical because we do it all the time. And just ask the FBI how hard it is to break. Now, on the decryption side, that's really the key, right? It's actually quite easy to encrypt data. It's getting it back that's harder. So if we can do this inline, and we can do it by policy so it can scale, then we have the freedom to use lots of different keys that are dynamically generated and used as needed. And the decryption happens as needed. So that would take care of our boundary situation. If we have the defense in place, and it's pretty solid, and you've probably heard, the best defense is a good offense, right? I haven't found any security professionals that agree with that yet. It seems to me, from what I hear, the best defense is really having just the best defense. Having some offense would be a nice change of pace in this war, all right? So the things, as we were already covering, watermarks are a fabulous tool that fit a little bit more on the offensive side because now I can understand where the content went if it got loose. Honey. Honey is great in all forms. I like honey. But pots, nets, and tokens are one way to lure the attackers to expose themselves and trip certain wires in your infrastructure or the system that you've created. Going a step further, web bugs. Web bugs are like web beacons. So if somebody does grab some of the honey and takes it out of your facility or outside of your purview, now that beacon can go off and you can track the problem to a location, not just knowing that you have a problem. Because the end of it, the end goal is to expose the perpetrators. Once they're exposed, you can deploy real countermeasures that effectively shut them down. That's the end game. Now, there's a lot of things in here, and if we wish them all together, we might end up with like kind of a jalopy, right? For those of you uninformed, this would be Homer Simpson's dream vehicle, right? I don't think it'll sell well. It may not even drive. That's not going to work for us. We need something very efficient. So again, from the storage perspective, we forked what we do with global file systems and created the damn secure file system. Now, most of this is already in place. The green parts are this virtual global file system that can track data regardless of where it lives. It can work with your existing storage systems. It can work with new ones. Really, it's a pointer-based system that presents a file system-like interface for humans to interact with. And in case there's some confusion out there between block storage, file storage, and object storage, let me sum it up real quick. Block storage is for propeller heads like me. We work with that really well. File systems are what we all work with pretty well. It gives us a hierarchy so we can organize data. Object storage is really cool if you're a machine. If I have an application or other machines that want to work with storage directly, give them object storage. But as soon as you put a human into it, you're going to have to go back to some sort of file system interface anyway. So the secure file system is the green parts. It organizes everything. It can use object storage on the back. It can use regular old storage. It can use your existing storage. The key here is that it's encrypting everything, and that it is only exposing it on an as-needed basis, right? So policies dictate when data is exposed. Is it safe to expose it and leave it exposed because the facility is secure? Or am I doing an ephemeral exposition of the data so that I only see it at a point in time and then it no longer is visible? So by policy, within the context, and as and where needed. That's the key, and it is possible to do that today with that kind of technology that we've covered. So the issues that we're, again, trying to address. Working together. This kind of a system, once implemented, can pour lots of data back into the security analytics layer, which gives you not only visibility as to what's going on, but that layer could report back and then start to take actions like shutting down compromised credentials. or rerouting data, or changing policies, because now it's been found out that we really can't expose data in this manner, in this place, and at that time. So let's just not do that anymore. That's just a change in policy that now impacts all of the data wherever it lives. We've also worked on the trust issue, right? So using multi-factor authentication, not just two-factor authentication, but also bringing in security context so we understand where things are happening and whether or not that should be approved. And then we don't have to worry about boundaries under this model. The reason is that the boundary is the data itself. That's now become the boundary, and I can decrypt at will. There are some upsides, right? Because if you took a look at that picture, it's not all that simple to implement something like that. So the upsides are, this is a data layer model that allows you to put in things pretty easily, right? I can inject honey into this architecture and start to do offensive things from a security perspective. Of course, we're doing that because now the security teams and the storage teams are working together. Superior asset management. There are a lot of people that would really like to have superior asset management. This is a model that manages everything for you on policy and places it where it needs to be. That kind of management drives down cost. Now I cannot have 17 copies of a file because I know that I have 17 copies of a file. I've ID'd every one of them. I know exactly where they are, and I could then eliminate the extras. I also can put it on the proper tier of storage. Storage has different costs. We all know that flash is fast and tape is cheap. Well, with this kind of a model, you get to, by policy, put the stuff in the place that saves you money. Possibly this all ends up paying for itself. Depends on how you roll it out. So, next steps. So certainly there's always a lot to learn within the security realm. Being from the data layer ourselves, we've been learning a ton through this whole project. To that end, there's still more to learn, and from our website, you should be able to get the links to the reports from the Mandiant group. Yeah, I'll cover Mandiant in a moment. Verizon and Operation Blockbuster. Anybody here heard of Operation Blockbuster? Anybody hear of an episode at a major studio about 15 months ago where a lot of data whooshed out the door? Okay, so we can cover the Operation Blockbuster during the Q&A, but it's a sort of preliminary report about what happened that was published last week. Your thoughts. We would like to hear your thoughts in an upcoming roundtable that we'll be hosting together with the ETC on this project. And then we're also going to be doing a webinar shortly on how you can use software-defined technologies in order to build some of this today. I would say that 60 to 70% of it exists and functional. It's that other part that we're still working through. So, just a little bit more wisdom from a couple hundred years ago, which is worth imparting. When you start to feel secure is when complacency is most likely going to set in. So that's probably a bad idea for anybody. You don't want to fall for that. And this would be the time for questions.
All right, what kind of questions might we have on this one? So I wasn't familiar with that report. Could you tell us a little bit about this report? I don't know much about it.
Operation Blockbuster?
Yeah.
So the Mandiant report is very interesting because Mandiant was a firm that was brought in after the episode at the studio to try and sort out what happened. That puts them under NDA. They can't say anything. So a consortium of companies within the security industry thought it would be great to unravel this and post what happened so that others can learn from it. So Operation Blockbuster is at operationblockbuster.org. And the report is posted there based on the findings of the companies to how many different variants of malware were used in the attack. They gave a name to the group that foisted the attack. I believe the number was between 45 and 48 different flavors of code used to unlock and infiltrate the organization and steal the data. It's a pretty comprehensive attack. It took a long time. And it's very dangerous because if they were in that facility that long undetected, begs the question as to where else they might be. That would be the exposing part, right? we need to be able to unlock and understand these problems so that we can expose where else these organizations might be.